record this company. Okay, so it's great pleasure to have Myungbo Shim. He's gonna tell us about non-unitary TQFT from 3D angle for rank 0 SCFT. Please.
Thank you for introducing me. And hello, everyone. Today, I'd like to introduce my recent work on non-unitary topological field theory from 3D n equals 4 rank 0 superconformal field theory. This seminar is based on my recent paper in collaboration with Dongmin Gang, Sungjun Kim, Kim-Young Lee, and Masahito Yamazaki. In this seminar, I'd like to talk about an interesting correspondence between TQFTs and SCFTs in 3D. Here, we partially obtained modular data of non-unitary TQFT, which is characterized in terms of modular tensor category. And this modular data can be obtained by BPS partition functions in degenerate limit of n equals 4 rank-0 superconformal field theory. And as a direct application, we obtain lower bound for round 3 sphere pre-energy at S3, a true measure of IR fixed point degrees of freedom. This is a 3D analog of A anomaly in 4 dimension. And according to F theorem, this 3 sphere free energy is monotonically decreased along the RG flow. So this is a proper degrees of freedom, a measure of degrees of freedom. Here, let me briefly provide some important effects on n equals 4 supersymmetry, which has 8 real supercharges. Here, our symmetry group is SO4, which is decomposed into 2 SU2. Here, the 2 cartons of R and R prime, the SU2 carton, and we can also define 2 different carton generator of SO4 R symmetry R nu and A as a linear combination of R and R prime with additional parameter nu, which is most important parameter in this talk, which is defining property of rank 0 theory. Not a rank 0 theory, just it's a defines the degenerate limit of superconformal field theory in 3D with SO4 R symmetry. And n equals 2 language R nu equals 0 and A is a U1 R symmetry and U1 flavor symmetry generator. And here our parameter nu is a mixing parameter between U1 R symmetry and U1 flavor symmetry. And one of the important effect is in the IR superconformal fixed point, according to F maximization principle, this mixing parameter should be 0. And n equals 4 theory possessed 3 types of supermultiplet, which is called vector multiplet, hypermultiplet, and half hypermultiplet. N equals 4 vector multiplet consists of n equals 2 vector multiplet and n equals 2 adjoint chiral multiplet. And hypermultiplet consists of n equals 2 chiral multiplet and antichiral multiplet. in R representation and R bar representation. If the Gazy group is a pseudo-real, there is a relation between phi and phi bar, then degrees of freedom become just a half of H. So this is called half hypermultiplet. However, why do we interested in the theories with 8 real supercharges? The theories with 8 supercharges exhibit rich structures with their different dimensionality. First of all, 5D theory and 6D theories are predicted by string or M theory construction. Secondly, there's a lot of interesting theories such as class S theory or Seiberg-Witten duality and Argyll-Douglas theory, AGT correspondence, and so on for the 4D n equals 2 supersymmetry. In 3D case, we have 3D meter symmetry or Rosansky-Witten theory and 1D topological quantum mechanics and so on for n equals 4 supersymmetry. And this kind of theory has a rich structure of vacuum modularized space. Here, one of the natural invariant of the superconformal field theory is called rank. It is defined by complex dimension of Coulomb branch moduli space. And in higher dimensions, more than 3, there was no rank-0 theory. However, according to recent work on geometric engineering, there are 5D or 6D rank-0 theories are found, but it is still unclear whether they are interacting theory or not. If they are interacting theories, it would be interesting to think about this 5D, 6D rank-0 theory as well. In 3D, situation is a little bit different. Non-trivial and simplest rank-0 superconformal field theories are found by Gang and Yamazaki quite recently. And in addition to this, Coulomb branch and Higgs branches are exchangeable by 3D meter symmetry. So in the previous slide, we consider rank as an invariance of superconformal field theory. And here, the Coulomb branch and Higgs branch is exchangeable by 3D meter symmetry. So we need to modify the notion of rank invariant under the 3D meter symmetry. The refined definition of rank is the maximum values among the complex dimension of Coulomb branch or Higgs branch. By this modified definition, rank-0 means the theory with no Higgs and Coulomb branch. So rank-0 theory can only have a mixed branch or no vacuum moduli space. And why rank-0 superconformal field theories are interesting? First of all, there is some difficulties for the classification program of this rank-0 theory. Since this theory have no Coulomb and Higgs branch operator, so traditional classification program relying on this Coulomb and Higgs branch operator do not work properly. In addition, rank-0 theory has no flavor symmetry, since flavor currents flavor occurrence multiplet always contain Higgs branch operator or Coulomb branch operator. So there is only energy momentum tensor multiplet, and this makes difficult to perform conformal bootstrap program. For the same reasoning, the supersymmetry of rank-0 theories should not be larger than n equals 5. Now, we can define the very degenerate limit of n equals 4 rank-0 superconformal field theory. The degenerate limits are defined by certain non-trivial R charge assignment parameterized by mixing parameter nu. Taking the plus minus 1 for the nu and consider 0 real mass parameter or trivial fugacity variable eta for U1 axial symmetry defines the degenerate limit or Coulomb Higgs branch limit. And since superconformal index in the degenerate limit yields Hilbert series or Coulomb or Higgs branch. This is why the degenerate limits can be called as Coulomb branch limit or Higgs branch limit. For the rank-0 superconformal field theory, there is no Coulomb and Higgs branch. This means no local operator except identity operator. So
I have a question. In that case, does the superconformal index is just trivial one?
yeah.
Okay. I see.
For the rank-0 theory, there is no local operator.
Okay.
Superconformal index become Hilbert series on the Coulomb branch and Higgs branch.
Yeah.
Is local BPS gauge invariant operator. However, this means there is no local operator. And similarly, topological field theory have no local operator.
Yep.
This is one of the most strong evidence for topological theory from the superconformal field theory. So this is one primary check for the obtaining topological theory from superconformal field theory.
Okay, I see. But it looks to me kind of was a boring theory to me. But is there some interesting dynamics? I mean, it's not. I mean, it's TQFT. Oh, okay. I just listen. Sorry. Maybe you can go ahead. That's you're going to explain, I guess.
And we defined the general limits of superconformal field theory. So we are now prepared to introduce our main proposal. First of all, non-unitary TQFTs emerge from n equals 4 superconformal field theory in the degenerate limit. In the partition function level, we can obtain partition function of topological theory from the supersymmetric partition function of rank-0 theory in the degenerate limit. And second, we can initiate the classification of n equals 4 rank-0 superconformal field theory. Because topological field theory is mathematically well defined in the language of modular tensor category. And the classification of a modular tensor category is intensively done by mathematicians, and we map the classification of superconformal field theory to the classification problem of topological field theory. And not only for the partition functions, we also established some dictionary between non-unitary TQFTs and rank-0 superconformal field theories. Our dictionary is summarized in this table. For some reason, I omitted the part on spin or non-spin TQFT here. However, the basic structure is parallel between spin and non-spin topological theories. First of all, this first law told us that the topological field theory has same partition function, which is obtained from supersymmetric partition function in the degenerate limit. And except for the last one, the rest of dictionary will be explained in the later slides. And here, I'd like to emphasize this last dictionary is very interesting. And this last dictionary told us from the minimum value of S-matrix component in the modular tensor category, and we can obtain the three-sphere free energy of corresponding n equals 4 rank-0 superconformal field theory on IR superconformal point. Here, it is not defined in the degenerate limit. Interestingly, from this dictionary, we can obtain the free energy on the three sphere, which is a genuine measure of degrees of freedom, which is monotonically decreasing along the RG flow. So let me explain this dictionary first. Here, I'd like introduce the first direct application of our dictionary and with some facts on the topologically twisted index or ground state degeneracy of topological field theory.
I have a question. So this topological twisted index, when you said sigma g is just sphere, g equals 0, it becomes the Hilbert series of Coulomb branch in Higgs branch.
Yes.
But then, so this rank 0 theory doesn't have a Higgs and a Coulomb branch. So isn't that just 1 when g goes to 0?
Yeah. Yes.
But then, yeah, I don't understand. So all the ground state degeneracy is just 1?
No. With a different number of genus, we have a different number of ground state degeneracy.
So it depends on genus. So when you say I is equal to 1 to R, right?
Yeah.
Those are ground state degeneracy, isn't it?
Yes. This R is a Witten index of the superconformal field theory.
Yeah. R is with the index that I agree, but then G equal to 0, you get the non-trivial answer.
But in the degenerate limit, this reproduce superconformal index.
So which is 1, right? Which is 1.
Which is 1. And
but G equals 0, your formula doesn't give us 1.
But that gives a non-trivial constraint on this modular data xi.
I see. So you just give you all sum over xi is equal to 1. That's what you mean.
Yeah.
Oh, I see. I see.
Yes.
Okay, thank you very much.
So let me resume. From the dictionary, topological twisted index is a partition function on S1 times sigma g. And as Satoshi said, g equals to 0, it reproduces superconformal index in the degenerate limit. And from our dictionary, this supersymmetric partition function on S1 times sigma g in the degenerate limit corresponding to ground state degeneracy of topological theory on the Riemann surface of genus G. And regardless of our dictionary, it is known that topologically twisted index or ground state degeneracy is topological invariant, and this value should be integer. And in terms of modular data, here let me briefly denote the modular data be xi. Xi will be related to S-matrix component of modular data. And known formula for ground state degeneracy on genus G Riemann surface is sum over xi with the exponent 1 minus g. Here, root x1 is supposed the three-sphere partition function at the degenerate limit, and root x2 is three-sphere partition function at the IR superconformal point. Is x2 related to three-sphere pre-energy? And there is a non-unitary condition for our theories. This told us the condition x1 should be larger than x2. And we will talk about unitary condition later as well. And we have three equations for the, actually more than three, but for small Witten index R, we use the R equations, and the most basic one is superconformal index is the 0. So sum of all the x's should be 1. And but the equations regarding Witten index R is just trivial equation, but it is used for the lower bound for three-sphere free energy of rank-0 theory which have Witten index R. And the next meaningful equation is genus 2 case, which have some integer value. It's different for each theory. And considering Witten index 1, this means we have only x1, and this gives trivial result. So we can start this classification from R equals 2. And for given Witten index, we can combine the fact that sum of all the x's equal to 1, and and from the non-unitary condition, x2 is the minimum value, and which is smaller than 1 over R. And this leads us to the lower bound of three-sphere free energy. should be larger than half log R. This is the most primitive application of our dictionary, and we will refine this lower bound for R equals 2. A minimal non-trivial topological theory have one simple object, two simple objects. One is an identity operator, and the another one is a non-trivial one. And we have two x1 and x2. We define x1 is a small, larger one, and x2 is a related three-sphere free energy. And combine these two equations with an arbitrary integer value k, and it is just solving quadratic equation. So x1 and x2 are given in a simple way, and k, we consider k is integer value, so k should be larger than 4. So for the minimal theory, k should be 5, and we obtain the smallest three-sphere free energy, and substitute the x2 minimum with this value with k equal to 5. This give a minus log root 5 minus root 5 over 10. This is this satisfied our primitive lower bound with r equals 2, this one. And interestingly, this is saturated by the theory found by Gang-Yamazaki. So we will call this theory is a minimal rank-0 theory.
I have a question. Why do you get this free energy of S3 partition function out of this xi? What are the physical meaning? Is this observation, or is there logic behind?
The discovery itself is observation, but the S3 free energy is a measure of degrees of freedom, which is monotonically decreasing along the RG flow. And we can set a lower bound for the all n equals 4. Superconformal field theory. Since this minimal rank-0 theory have smallest amounts of degrees of freedom.
Okay. But I just don't understand why this root, I mean, the twisted partition function knows about this S3 free energy.
Could you tell me once more?
So why this twisted index tells us the free energy on S3?
I see. This,
yeah, why does it give us some information about S3 partition function?
That is the observation.
Observation, okay, okay.
This dictionary itself is observation, and however, the algebraic constraint of ground state degeneracy and this dictionary combine each other, and this leads us to the universal lower bound for three-sphere free energy for all the n equals 4 superconformal field theory.
Okay, okay, go ahead.
And to obtain modular data of topological field theory, the way to obtain this ingredient to compute modular data is supersymmetric partition functions, and we use the localization recipe to compute these supersymmetric partition functions and in the degenerate limit of rank-0 theories. And in addition to this, modular data can be obtained from Bethe-Vacua method. Our target supersymmetric partition functions are S3 partition function to obtain three-sphere free energy, and Squashed three-sphere partition function to use Bethe-Vacua method. And to check the hint of topological field theory, we compute S1 times S2 partition function as a superconformal index. And so as a generalization, we also consider S1 times sigma G partition function, which is a topologically twisted index. And G equals 0 case will reproduce superconformal index. And as we said before, superconformal in the degenerate limit is give Hilbert series on the Coulomb branch or Higgs branch. And trivial superconformal index, this means there is no local operator, but there could be non-local operator in the theory. To compute or check this trivial superconformal index, we may use supersymmetry localization recipe for S1 times S2 partition function. The generic structure of superconformal index with a gauge group is given in this way. And here I omitted the explicit details of localization, but the relevant and necessary information on the localization recipe is in our paper. So for more details on this, please consult our paper. And in the similar way, we consider supersymmetry localization on Squashed three-sphere partition function. And using the Squashed three-sphere partition function, we can make use of method of Bethe-Vacua. In this formalism, we can extract the Handel-Gluing operator and fibering operators from the Squashed three-sphere partition function, and general topologically twisted index can be constructed in terms of Handel-Gluing operator and fibering operator computed from Squashed three-sphere partition function. And the generic structure of Squashed three-sphere partition function is similar to the superconformal index, but we have an additional parameter h bar. This is defined with squashing parameter b. Here, we expand perturbatively in terms of h bar. Then twisted superpotential w's are obtained as a coefficient of h bar order. And after the perturbative expansion, we can approximate this integral as using the center point approximation. And then we can expand this integrand around the center point. Then we can obtain center point equation for the integration variable zi. Then zi's are solution of the center point equations called Bethe-Vacua. Here we define the Bethe-Vacua not only just for the solution of this center point equation, but it is defined up to the while group of our gauge group G. So we need to quotient by this while group, and handle gluing operator H and fibering operator F can be computed by tree-level expansion and first one-loop order expansion in around center point expansion. So we can compute H and F up to some base vector in the degenerate limit. These two operators will be related the component of modular S-matrix and modular T-matrix. For the non-spin topological theory, T-matrix is completely determined from this fibering operator. But for the spin topological theory, we only know the partial dictionary for this T-matrix between F operator. And handle-gluing operator give first row or first column of S-matrix. Then and from this handle-gluing operator and fibering operator, we can construct the general supersymmetric partition function on MGP. Here G is a genus of a Riemann surface, and here P is a first Chern number. And consider P equals 1, the topologically twisted index on S1 times sigma G is constructed by only handle-gluing operator with exponent G minus 1. And using our dictionary, this gives ground state degeneracy of topological theory on the Riemann surface sigma G. And consider G equals 0 case, we recover trivial superconformal index as a check of topological theory. But we need to kill the other entries in the S-matrix and other modular data of topological field theory. Here we can call basic operator or anyons in terms of a supersymmetric loop operator. And here W matrix is eigenvalue of this basic operator. And fusion of anyons can be described by this fusion coefficient N. And however, we don't much worry about this N, because this N fusion coefficient can be obtained from S matrix by the famous Valinde formula. So our primary interest is S matrix and T matrix in the modular tensor category. And there is a unitary condition for our modular data. This unitarity means simply the modular S matrix is unitary. This reads the S00 component has the minimum value in the S first row or column of S matrix. And non-unitary condition simply means S00 component is not a minimum value. And combining with the dictionary for three-sphere free energy, this might be related to the F maximization principle. And classification of topological field theory by the rank of modular tensor category or Witten index are intensively done by mathematicians along the decade. And unitary modular tensor categories are classified up to rank 5, and above the rank 5, there is only partial list of classification. And I have recently the fermionic modular tensor category or spin topological field theory is classified by these people. So using the fact that the classification of topological field theory are well defined in a mathematical way, so we can map the classification problem of n equals 4 rank 0 superconformal field theory in terms of modular tensor category. And by using the classification of modular tensor category, we can classify the n equals 4 rank 0 CFTs. And once again, what I explained before are summarized in this table. First of all, we start from rank 0 n equals 4 theory, considering the degenerate limit defined by 0 real mass parameter and plus minus 1 mixing parameter nu of SO4R symmetry. Then we can obtain trivial superconformal index, which imply there could exist topological field theory, and compute Cauchy's three-sphere partition function. We can extract Handel-Gluing operator and fibering operator from the Bethe-Vacua method. Then we can partially recover components of S-matrix and T-matrix. And also we can compute the W-matrix to complete the entries of S-matrix. In addition to this, we accidentally found the map between S-matrix component and three-sphere free energy of superconformal field theory in the IR fixed point. From now, I'd like to demonstrate this procedure as an example. And for the simplicity, we consider minimal rank 0 theory. And this theory have a UV Lagrangian description, n equals 2 U1 Chern-Simons theory with a chiral multiplet of charge 1. Chern-Simons level K is a -3/2. In the IR fixed point, supersymmetries are innest to n equals 4. And this is a minimal theory in the sense of it has minimal degrees of freedom. Before found its three-sphere free energy saturated by this theory, we can compare the central charge of this minimal theory with the single free theory for chiral multiplet, and we can find this minimal theory has smaller central charge, even though the central charge is not the proper measure of degrees of freedom, but this indicates this theory could be minimal, could have minimal degrees of freedom. And after this demonstration, we could check this has really has minimal degrees of freedom in the n equals 4 theory. And as we said before, we primarily check the trivial superconformal index in the degenerate limit. Here's the superconformal index in the IR fixed point, and turning on new parameter plus minus 1, we give this expression, and taking the trivial eta, all the coefficient vanishes, and we obtain trivial superconformal index. And we can also reproduce this fact from the twisted index, taking genus equal to 0. Now it's time to compute modular data from our Bethe-Vacua method. And we know the Lagrangian description in the UV fixed point, and we have Chern-Simons level and R charge and conformal dimension of this free chiral. So we can construct the Squashed three-sphere partition function from the localization formula. Here, this psi h bar is a quantum dilogarithm function. Here, I omitted the details on this function. And after perturbative expansion in terms of h bar, and we can expand this integral for the saddle point approximation, then we can obtain saddle point equation. This is in this way. And the solution of this saddle point equation with the trivial m and plus unit u value, we can obtain the Bethe-Vacua in the degenerate limit. When using this Bethe-Vacua and the saddle point approximation of the three-sphere, Squashed three-sphere partition function, we can compute Handel-Gluing operator and fibering operator in the degenerate limit. Then we can obtain this analytic expression. And from these two vectors, we can fill the entries T matrix. It is completely filled. And using this Handel-Gluing operator, we can fill this first row and first column. So this S11 component should be filled out. To complete the modular data, modular S-matrix, we need to identify anyons with supersymmetric loop operator of our minimal theory. Here, the supersymmetric loop operators are parameterized electric charge P and magnetic charge Q. And vacuum expectation value or eigenvalue of this operator are computed in terms of Bethe-Vacua with the exponent P and Q. And we can identify the two anyons in Lee-Yang topological field theory. So we can easily find what is identity operator, and we can find the non-trivial one is electric loop operator. Then using this formula, we can compute this W matrix. Then W matrix is a ratio between S matrix component. Then we can finally fill out the remaining entry. So now we have complete modular S matrix and T matrix. And from using the Valinda formula, we can compute fusion coefficient matrix N matrix, and we can recover fusion load of the anyons. And to support our unproved proposal, we consider infinitely many examples by considering gauging of TSU2 theory. And beside of TSU theory, we also consider U1 Chern-Simons theory with a hypermultiplet and SU2 Chern-Simons theory with a half hypermultiplet and half hypermultiplet. And this theory is a n equals 5 theory. This is the only example of our project. So all the other theory have n equals 4. So this n equals 5 theory have a mixed branch, and so for the U1 Chern-Simons case, only the Chern-Simons level 1 can be enhanced to n equals 4 theory. And here we didn't discuss about this gauging of TSU theory, but we made a fluent explanation in our paper. So for more details on our example, please consult. So here, let me summarize our discussion today. First of all, non-unitary topological field theory can be obtained from superconformal field theory of n equals 4 rank-0 theory in the degenerate limit, which is defined in terms of mixing parameter plus minus 1 and the vanishing real mass parameter or trivial U1 axial gas eta. And secondly, we made a dictionary and we compute lots of examples to support our dictionary. And from the direct application of our dictionary combined with algebraic constraint on the modular S matrix, we can find the lower bound for 3-sphere free energy for all the n equals 4 superconformal field theory in 3D. And we also confirm the minimal theory saturate the lower bound for the degrees of freedom. So now we can hold this theory without no minimal theory without no doubt. And in the paper, we discussed about spin TQFT or anion condensation and regarding the gauging of TSU2 theory. So for more information, please take a look at our paper. And I'd like to discuss about the natural questions arose during this project. First one is classification of a rank-0 theory and the duality. what if the two different superconformal field theory have the same topological field theory? Does it imply the duality? In our brief answer is seemingly yes, but we need more evidence. The another one is the topological field theory can be obtained by topological twisting from Rojansky-Witten theory. This yields unitary TQFT, even though it does not satisfy all the axiom of topological theory, but it has a same ground state with a our non-unitary TQFT. So we conjecture this unitary topological field theory from Rojansky-Witten theory might be a Galois conjugate of ours. And it is also known that from the 4D n equals to Argyros-Douglas theory, we can obtain the non-unitary TQFTs. And we would like to address what is the relation between ours and theirs. Thank you for your attention. And
thank you very much. Question from audience? There is a question in chat from Ken Kikuchi. How did you fix the overall sign of S-matrix?
Actually, the overall sign is the remaining problem to address. So we only consider the absolute value of S-matrix component from the handle-gluing operator, because we can only obtain the handle-gluing operator up to some phase vector, and this phase vector is not fixed. So the overall sign is still problematic. Is it the answer to you?
Oh.
Oh.
Can you obtain all MTC lower ranks using this approach?
Yeah, for the R equals 2, we can obtain all the entry of S matrix and T matrix, but there is a lot of modular data inside of S and T matrix in the MTC. For example, R matrix and so on. But so far, we can only talk about the S matrix and T matrix with a N matrix from Berliner formula. And for the large length, it is difficult to find the identification of anyons and supersymmetry loop operator. For example, R equals 2, as you see this slide, it is easy to find the whole identification. So in that case, it is possible at least for S and T matrix. But R equals 3, it is quite difficult to find all the identification with the loop operator.
Any other question? You can unmute yourself instead of typing.
Thank you.
So I have a question. So usual 3D integer 4.
Yes.
Does this sum of a Bethe-Vacua works for arbitrary non-abelian gauge field? I mean, I know abelian case it'll work. This when you try to compute topological twistor index, the sum of a Bethe-Vacua works for abelian for the 3D n equal to 4 theory. Yeah, 3D n equal to 4 theory. But for non-abelian case, so I tried some of the whatever SQCD and for non-abelian SQCD for 3D n equal to 4 case, some of Bethe-Vacua somehow doesn't work. That's my observation. Did you try?
We tried
like,
this.
Yeah, it seems like you use supersymmetric enhancement. You turn on Chern-Simon's term, right?
Yes, yes.
Then you use the supersymmetric enhancement to n equal to 4.
Yes.
That's why I think this sum of Bethe-Vacua I think works. But if you don't turn on like Chern-Simon's term and just use purely 3n equal to 4 non-abelian gauge theory, have you ever tried this method, this sum of Bethe-Vacua for this kind of purely n equal to 4?
I didn't try it, but
Okay.
I'd like to see because all of these examples are the Chern-Simon theory.
Yeah, I think that's why it'll work.
Yes, so we'd like to generalize this kind of example for the other kinds of theory, for example, no Chern-Simon's term.
Yeah. Did you try that?
Unfortunately, we didn't try this.
Oh, you haven't tried.
I'd like to do.
Yeah, can you try and then tell me whether it works?
Yeah,
I personally tried this 3D n equal 4. I mean, topological index. I tried to compute non-abelian case, even the simple SQCD. SU2 with whatever NF hyper, the simplest one, 3D n equal 4, and try to compute topological twist index. It never works. The sum of Bethe-Vacua, it never works. Maybe I may be wrong.
We need to find out.
Yeah. Please.
Topologically twist index.
Yeah, I mean, but we know that when G equals 0, it's Hilbert series.
Yes, in the degenerate limit, give a Hilbert series.
Yeah, I mean, topological twist is not superconformal index. Topological twist index on genus equal to 0 is Hilbert series. And then try to do the sum of a Bethe-Vacua, but it never gives the Hilbert series. You need to add some additional contribution. I mean, please try if you understand, and tell me. I may be wrong.
Yeah. They should be addressed in the future.
Okay. Any other question from audience?
Yes, I'm sorry to ask a question based on some vague understanding. So was Satoshi's comment or question about relating S3 partition function with superconformal index? Like an superconformal index is like S2 cross S1, right? And
yes, S1 cross S2.
And the idea, I think so you somehow relate the theory on S2 cross S1 and S3. Is it true? Or it's not like that?
Yeah, something like that. Something like that. It's more like as far as I understand, he connect the twistor index S1 cross S sigma G. And from there, he can try to extract the modular S-matrix. And then somehow when you take a log and the max, you get this 3-sphere free energy somehow. I don't know why.
So it reminds me of some idea of holomorphic block have you ever heard the word block? So because S3 and S2 cross S1 can be both computed by gluing
solid
this S1 and each fixed point and how we glue is different. So I wonder if it's your idea is related to this.
It should be, but I don't know. It should be. It should be.
Like,
there is some connection between.
But I don't
not
know
directly for the moment.
Yes. Yeah.
I see.
In the present status, this is kind of accidental discovery.
Okay.
And we don't like to find why this happened. This dictionary holds
I see.
for this.
I see.
Mhm.
One more question, which is even more based on very vague knowledge. I heard of the statement that the necklace of partition function can be also identified as a partition function of topological field theory or something like that. Have you ever heard such a statement? And I wonder if it's related to what your idea. Like,
is it a case of a 4D, right?
Sorry?
4D, is the 4D necklace partition?
4D necklace of partition function, yes. Of course, I noticed that the dimension is different, but the idea is similar or completely different.
There is a question about the relation between this n equals 2 4D theory. Maybe the necklace partition function for this theory.
I think how does, I already forgot, but how does the Hilbert series to ADHM is related to necklace of partition function? I should have known actually. Hilbert series. For instance, if you consider 3D n equal 4 theory with the Jordan type, like whatever say, outer joint with this ADHM construction with fundamental hyper, then Higgs branch is the really instant modular space. And if you consider, I think this twisted partition function will give you the data of this Higgs branch modular, Higgs branch, which is the instant modular space. So that's how you connect the necklace of partition function with this topological twisted index. But I should have known, but I don't know the direct relation. Do you understand what I mean? I mean,
I try to.
3D n equal 4 of this how to say UK with that joint with hyper, one fundamental hyper. The Higgs branch of this 3D n equal 4 theory is the instant modular space, K instant modular space. And then if you consider twisted index of this theory, it should be related to necklace of partition function. But I don't know how.
Sorry, I not that familiar with the 4D necklace partition function.
I already forgot. Yeah.
But I'd like to check.
Yeah, so there must be a relation between S1 cross S2 with the index of this 3D n equal 4 theory, ADHM cleaver. Should be related to necklace of partition function.
Yeah, I see.
Yeah. But that's the only thing I can make a comment. Only relation.
Help to the Futoshi.
I don't know if it answers to the Futoshi's question.
Maybe.
Okay, maybe not.
Yeah. Okay, anyway, thank you.
Any other question? Okay, if not, let's thank the speaker. Okay, I have another seminar in October. Yosuke Imamura talk about the superconformal index. So see you next month.
Yeah.
Okay, bye.
Bye.